Hello students, welcome to the Mechanical Engineering Department of Swami Vivekananda Institute of Science and Technology. Myself Dr. Koushik Mishra and I am the Assistant Professor of Mechanical Engineering Department. So today we'll be learning about manufacturing technology and module 4, which will be on NC and CNC. There is a history behind NC and CNC, and John T. Parsons is the father of NC machine. It was first developed in the year 1952 by the team of researchers working at MIT, and it was first patented in 1958. So what is the need of NC or CNC machine? As we know, the conventional machine as the most important parameters are feed rate, depth of cut and speed are manually controlled by the operator. So the accuracy of the job depends essentially on the skill of the worker. So these machines have the following disadvantages. What are those? More time consumptions, less accuracy, less production, required skilled labor and more wastage of materials. So for these reasons, computer numeric control comes into the place. So it is a method of controlling the manufacturing operations through numerical instructions in the form of directly inserted coded in the machine tools. It is important to understand that NC is not a machining method, rather it is a concept of machine control. So what is NC machine? Here NC stands for numeric control and is defined as the machine which is controlled by the set of instruction in the form of numbers, letters and the symbols. The set of instruction is called as a program. So numeric control is a machine tool which is operated by a series of coded instructions that include numbers, letters of the alphabets and symbols. And the machine control unit can read. These instructions are converted into the electrical pulses that the machine motors and the control follow the performing manufacturing tasks on a workpiece. Numbers, letters and the symbols are coded instructions that apply to specific distances, positions, tasks or speeds that a machine tool can understand as it machines the workpiece. And it's a numeric control refers to the method of controlling manufacturing operations through numeric instruction directly coded in machine tools. Numeric control can be defined as programmable automation over which the process is controlled by the numbers, letters and symbols. So there are three basic components are in the CNC. What are those? Those are program of instructions, machine control unit and machine tools or processing equipment. So these three are the big components of one CNC. First one is the program, second one is the MCU, that is machine control unit, third one is the machine tool. So first one is the program of instructions. The program of instructions is a complete step-by-step set of instructions that tells the machine tool what to do. It is coded on some type of input medium in a numeric or symbolic form that can be interpreted by a controller unit. Today's most common input medium is alien white tape. Over the years, other kinds of input media have been used, including punch card, magnetic tape, and even 35mm motion picture film. There are two other methods in input in NC systems that should be mentioned. The first is manual entry of the instruction data for the controller unit. This method is called manual data input, decreased MDI, and is not suitable for relatively simple jobs where the command will not be repeated. Other methods of input are through direct links with computers. This is termed as direct numeric control or DNC. So the programmer's job is to provide a set of detailed instructions by which to order to the processing steps. The relative movement between the cutting tool and the workpiece are controlled by the instructions. So second one is the machine control unit. So it is like a brain of a machine. So machine control unit it includes electronic and hardware that read and interpret the program of instruction and convert it into mechanical functions of machine tools. So series controls to coordinate overall operation of the foregoing elements are tape reader, signal output unit, and sequence coordinator. So the third one is the machine tools. It can be any type of machine tools or tool. The third basic component of NC system is the machine tools or other control process. It is a part of NC systems that perform useful instructions. So the basic components of the machine tools are structure, screw nuts and guideways, spindle drives, tool changes, and lubrication systems. So the fourth units of the NC system is drive units. So servo and stepper motors are used as the drive units, and another important thing is the feedback unit. This unit is also known as position feedback package. Feedback unit feedbacks the information about the actual position of the movement to the control unit. The control unit compares the actual movements with the required movements. If there is a difference, the drive units are actuated to do the necessary corrections. So sixth one is the magnetic box. The magnetic box receives electric signal from the control unit for all other activities except for the servo motor drives. Spindle motor starting and stopping, selecting spindle speeds, making tool change, control of coolant supply, etc. are directed from the magnetic box. The control panel is the another important thing, another element of the NC systems which may be actually part of the controller unit or machine tool is the control panel. It may also include data display to give information to the operator. Although the NC systems is an automatic system, the human operator is all needed to the machine on and off to change tool to load the unload. So this is the free body diagram of lathe, vertical milling and horizontal milling machine. So as we can see in the figure that uh, there are only two axes in lathe, that is X and Z. There are three axes in vertical milling, that is X in this direction, Y in this direction and Z in this direction. And as the horizontal milling machine, where Z in this direction, X in this direction and Y in this direction. NC machine has lot of applications, not only some machining applications but also non-machining applications. The machining applications of the NC machine includes milling, drilling, turning, boring, grinding, and machining centers, turning centers, mill turn centers, punch presses, thermal cutting machines, etc. Other than machining applications, it has also some non-machining applications like drafting machines, component insertion machine, coordinate measuring machines, tape lying machines, filament winding machines for polymer composites. NC and CNC machines are taking a lot of attention in the modern manufacturing industries due to their several advantages. Some of the advantages compared to the conventional machining are greater operational safety, greater operation efficiency, reduction of scrap, reduced lead time for production, fewer changes of human error, maximum accuracy of interchangeability of the parts, lower tooling costs, greater machining tool safety, and greater machine utilization. So besides the lot of advantages, NC-CNC has also some disadvantages, like the cost of the machine is very high. Programming training is required to operation the or to code the program. A skilled programmer is required to perform the operations. So higher maintenance cost and higher skilled workers are needed, which are the disadvantages of NC machines. Thank you. See you in the next class.